to make sure Carole has all the permission she needs. Andy, could you set Professor Mundell to be a co-host, please?
Oh, sorry, I will do that now. Just 1 second.
I've unmuted, but I don't have video yet.
Okay, 1 second. All right, here it is. You are now co-host.
Wonderful, perfect. Good morning.
Good morning. So welcome everyone to our first session. I'm delighted to introduce our first speaker for CUWiP 2021, Professor Carole Mundell. So Professor Mandel is serving as Chief Scientific Advisor at the Foreign Office, the Foreign and Commonwealth Office from 2018, and in this January was appointed Chief Scientific Advisor. She's a Professor of Extragalactic Astronomy and the Head of Astrophysics at the University of Bath, and is a Fellow of the Institute of Physics. Her career highlights include the Royal Society Wolfson Research Merit Award for 2011 to 2016 for her study of black hole-driven explosions in the dynamic universe. And also the FDM Every Woman in Technology Woman of the Year Award in 2016. She's a world-leading scientist. She's been a frequent guest speaker at international conferences, and she sits on a number of strategic advisory panels for the UK and other international groups. And she is a committed communicator of science and a very public advocate for diversity in science. So we're very privileged to have her join us today. Before we start our talk with Professor Mundell, I just wanted to let everyone in the audience know we will be collecting questions during the talk. There should be a link going into the chat from some of the other local organizing committee for a link to VVox. So VVox is an app you can open in your browser or on your phone. You'll be able to type in questions there and upvote the ones that you most like to hear. And then once we get to the end of the talk, we'll start reading down those questions. So keep an eye out for that link in the chats. We'll post it at the end as well. But yeah, so welcome, Professor Mundell. Thank you very much for coming.
It's a great pleasure to be here and a real honour to be the first meeting of the day. And it's great that you can have so many people online as well. I think we've all had a differently difficult year, but I think it's wonderful that we can all connect. And I would just agree with the comment that was just made about imagining you're in a room with 107 women, which I think for many of us in physics is a very unique feeling. But I'm certainly imagining being in the room with you all. So it's lovely to speak to you today, Imogen.
Yeah, it's my pleasure too. Thank you for coming. I keep saying that, but it's true. For those in the audience, the format of this is we're going to have a bit of a fireside chat, an interview, if you will. So I've got a list of questions I wanted to start off with, but do jump into chat with other questions you want as well. So the list of questions I've got kind of almost starts chronologically. So I'd love to hear sort of what inspired you to start in your journey of physics when you were young, when you were at school?
So yeah, I think, Imogen, begin at the beginning. I've been reflecting on this recently, actually. I had a really interesting conversation with my mum, and she remembers a dress when I was about 6. And it was a very pretty dress, and I remember it had fruit on it, and this I called my maths dress. And I didn't really remember why, but we managed to find this photograph in an old photograph album a little over a year ago. And I scanned it, and I zoomed into it. And what I realized was that this wasn't just a pretty frock with fruit on it. It actually had mathematical equations on it. I didn't know this all my life. And those mathematical equations, it wasn't just a bit of algebra, 1 apple plus 1 apple equals 2 apples. It was actually integral signs. It was summations. It was these magical symbols. So I do wonder now, and I guess I won't know the answer ever, but whether, that obsession, I remember being at a child's party and trying to read these symbols upside down. That's probably one of my earliest memories. And so in some ways there was that curiosity about these magic symbols that maybe softened my brain up. And I was very good at solving puzzles. I loved to solve puzzles. So for me, certainly as a teenager, doing equations around the space on the newspaper, in front of the TV was not really studying. And whenever my parents said, "Are you studying for your exams?" I was like, yeah, I'm playing with equations. So there was some kind of fun about playing with equations and solving problems. But actually what I really wanted to be when I was a child was a ballroom and Latin American dancer. So I was not one of those children like, many of my colleagues are, who had a telescope at the age of 7 and studied the universe. Didn't know much about astrophysics, didn't know much about astronomy, but I actually started to really love physics as I went through my teenage years and then into A levels. And so I took further maths and physics A level, and then I went to university to do physics and maths. And actually I studied at the University of Glasgow. The system there is slightly different. I came from England with A levels, and I was encouraged to go into the second year because the first year was really for students coming into university at the age of 17. But I sort of wasn't sure about that. I wanted to be with the first year cohort. And so I was told by a very illustrious senior male physicist, well, you'll have to do something else. I also was a keen musician, so I wanted to take music, but my illustrious professor colleague didn't think that, or my professor didn't think that music was a proper subject, which I disagree with, obviously, but fair enough. And so actually I took astronomy, and it was a subject, I think probably in the first year, that bemused me. It was very different to physics. You could get an order of magnitude and you were pretty close. And as any astronomers on here today will know, if you get your answer to within a factor of 2, that's really accurate. And I found that absolutely almost ridiculous. I was kind of, well, there are 3 unknowns in this equation, therefore I can't solve it. I came with a physics mind. But actually that journey really took me through. And then at the end of my degree, I did do, my degree's called Natural Philosophy and Astronomy, which sounds as though I did no maths. So I had to explain to lots of people that actually it was almost effectively theoretical physics. And then it was really at that point that I didn't know what to do. So I had a job offer in the nuclear industry. I'd had a summer job. I really loved that, the idea of having a really good salary and flexible working and all sorts of exciting stuff like that. I'd made friends in the company that I'd worked in. But I also had an offer of a PhD place at Jodrell Bank Observatory in Cheshire. And when I went to visit there was this giant telescope, there was digital electronics, there was something so different to my degree. It was so incredibly practical, and it was too good an opportunity to miss. And I was very fortunate actually, because the company said to me, "Oh, that sounds fantastic, go have fun for 3 years, do your PhD and we'll keep your graduate training place open for you." So it was really great to have those options. And I think that's the one thing that I've carried throughout my career, always have options, and then that gives you choices. So as many possible futures, and then you can pick the one that suits you at the time.
Oh, wonderful. So you mentioned Jodrell Bank Observatory. I think it's a lot of us know it as a very famous radio astronomy site for its huge radio dishes. So what did you do as part of your PhD while you were there?
So my PhD was actually studying atomic hydrogen in galaxies. And again, a lesson for everybody listening, things don't always go according to plan in your career. And so when I first picked the PhD project, the way Jodrell Bank arranged things in those days, and they recruited students onto the PhD program and also onto a 1-year master's program. And we all did almost like a graduate training program for the first 6 months. So we went to lectures and we were all brought almost to the same level, whatever our background was, which was really exciting. And then the only difference between masters and PhD students was the length of the research project that you then took on. And so the project that I'd originally applied for was actually to use the Merlin interferometer to study the radio continuum emission from active galaxies and to look for small radio continuum jets, so the ejection of plasma from supermassive black holes in nearby spiral galaxies. And my my supervisor had put in a telescope proposal to the Merlin committee just before I took the project. And actually the proposal was rejected. So as I stepped into my project, he basically said to me, there's no data, you've basically got no PhD, what do you want to do about this? And again, that sense of flexibility, but he did have some data lying on a tape, which actually came from a very different instrument, which is a very large array, 27 radio telescopes networked together in New Mexico in the plains of San Agustin. And it was kind of, well, there's some stuff on the tape, I haven't had a chance to write it up, why don't you go play with it? So it was a little bit daunting, but I'm quite curious, as I say, I like to solve problems. So I started to learn very much by myself, manipulating the data, and that turned actually into a really nice stream of research throughout my career. So really the goal we were trying to address was to understand how supermassive black holes at the hearts of galaxies become active. And then start to produce bright radiation, X-ray and ultraviolet, and also sometimes to launch these radio jets. And what was the role of the material in the host galaxy, which is in principle a vast reservoir of potential fuel to feed these black holes. But of course, it's very difficult to stuff that material into the black hole because the material has angular momentum. And so that was really the part of my PhD that I started to develop. But again, I was a bit of a misfit. It'll make me feel quite old now, but in those days, active galactic nuclei were considered to be a bit of an oddity. So they'd been discovered in the 1960s. Quasars were very well known to radio and optical astronomers, but these were distant, very, very powerful active galaxies, and you couldn't see their host galaxies. They just looked like point sources, so-called quasi-stellar objects. So I was working between two communities. When I went to conferences that were full of active galactic nuclei scientists, they were really looking right down at the accretion disk. They were looking at very intense X-rays, and they didn't much care about the host galaxies. Then when I went to galaxy conferences, where everybody cared about how galaxies formed and evolved, and the dynamics of galaxies and how star formation worked, all of those people were throwing out the galaxies with active nuclei out of their samples because they were considered to be too difficult to understand. So I was working at the interface between those two fields. And the big breakthrough really came in 1998 when John Gregorian published his paper that said all galaxies with massive bulges have supermassive black holes at their centre, whether they're active or not. So that's a supermassive black hole at the centre of a galaxy is a core ingredient of a galaxy, and then it will be triggered into activity or kind of cosmic indigestion at some point in its lifetime. Maybe episodically it will switch on and switch off, and that will also affect how the galaxy evolves. So it's really lovely to have those two fields that I was working separately in my PhD, really brought together. And now it's just a standard field of research internationally.
Oh, fantastic. So in continuing your career past PhD, so typically, I mean, for those in the room that don't know, there tends to be a period of postdoctoral research that then will lead to some funding via a fellowship, whether that's from a research council or the Royal Society or the EU, and so on and so on and so on. So how did you manage to sort of turn this very fruitful research into a sort of an academic career via those kinds of systems?
So I think I was very fortunate that I did win a number of research fellowships. So straight after my PhD, I won the equivalent of an STFC postdoctoral fellowship. And that again helped me to develop my research independence. After that, I was appointed to a postdoctoral research associate over in the United States at the University of Maryland. Again, very different science system, and helped me to grow as a scientist as well and make new connections and new collaborations. And slightly different to a fellowship because, it was more of a traditional postdoc where one's boss says, I'd like you to work on these projects, and you've got about 20% of your time for your own research interests. But the projects that he was offering were so exciting that it was a really good opportunity, and he was a very big name in my field. So I did that for a couple of years, and then I won a Royal Society University Research Fellowship back in the UK. So I came back on that fellowship, again still focusing on galaxies and active galactic nuclei and galaxy evolution. And I took that to Liverpool John Moores University, which was a very small research group at the time. And they just moved out of Liverpool to a new building building on the side of the River Mersey, and they were developing the Livable Telescope, which is a 2-meter robotic optical telescope. And in fact, it's the largest fully autonomous robotic optical telescope currently in the world. And I moved there, and I was starting to build my group around galaxies. And the head of research said to me, well, we have this robotic telescope that we're probably going to use for things like novae and supernovae. And he started to tell me about the technology. And at that point, the first optical counterpart of a gamma ray burst, which these are supermassive stars, so not supermassive black holes, are about 200 to 300 times the mass of our own sun. They're at the edges of the distant universe, and when they collapse, they form a black hole, and some fraction of them will shoot some relativistic plasma in a beam. And when that points towards Earth, we see a very bright flash of gamma rays. They were discovered by military satellites in the 1960s that were monitoring the Earth for violations of the Nuclear Test Ban Treaty. And then when it was discovered that they were actually extraterrestrial, they were not on the Earth, and it was nobody detonating nuclear weapons, the field pretty much languished because the localization of these things on the sky was very, very poor. So it was difficult for any other telescopes to find radiation from them, because you need to know where to look with an optical telescope. So the big breakthrough came just before I moved back to the UK in discovering the first optical counterpart. So I did say to the head of research, presumably you're going to look for these things because a robotic telescope's ideal. For my galaxy science, a 2-meter telescope was not really very big enough for what I wanted to do. And so he said, well, yes, we have a mode that could be developed to do that, but we need somebody to lead the science. Would you be willing to do that? So again, that was a new learning curve for me. So I'd been to a couple of seminars. I didn't know much about gamma ray bursts beyond anybody else. And I started to read and then think about what this new technology that we had, how that could be developed to really address some of the open questions in that field. And then over the next few years, I then built a small research group to be able to use that and use some of the guaranteed time that we had on the Livable Telescope, which I should say is not in Liverpool, it's in the Canary Islands. It was built in Liverpool, in Birkenhead, and then there were 2 other telescopes, 2 clones of that, one that went to Australia and one that went to Hawaii. So we then built this network of robotic telescopes to follow these flashes up in real time, which was a really exciting part of my career.
Fantastic, thank you. So sort of reaching the sort of the last few years of your career up till now, you've been involved with the as a chief scientific advisor for the Foreign and Commonwealth Office. So could you tell us a bit about how that opportunity came about and what it means to do that kind of role?
Yeah, for sure. So in 2015, I was appointed to become the founding head of astrophysics at the University of Bath, to build a brand new research group and also to start a brand new undergraduate program, actually to build a 4-year undergraduate program. So that was a very exciting and busy time for me. And after I joined Bath, I was then appointed to be head of the Department of Physics. I'd been head of the physics department for about 2 years. And I was approached by a recruitment company. Actually, I had a number of emails from them, which I kept deleting, as sometimes senior women do, because you don't think they're talking to you. And the lady in the recruitment company was very, very canny. And she phoned me up and she said, "Are you deleting my emails?" And I said, "Yeah, I kind of am, actually." So she said, "Do you want to come into London and have a conversation about this job?" So I knew about the government chief scientific advisor role. So that's Sir Patrick Vallance is currently in that role. I'd worked with some of his predecessors when I was a young research fellow, working on some science policy, and particularly around space science, which was really interesting through the Royal Society. But I didn't know that there are a network of chief scientific advisors across Whitehall, so one in every department, and that they form a network to support Sir Patrick Vallance in his role in advising the Prime Minister on science in emergencies and science policy more broadly across the whole of Whitehall. And this in particular was in the Foreign and Commonwealth Office, so it was very externally facing, it was very international, and we had a really nice conversation about it, and she encouraged me to pass my CV in, which I did. I went for a recruitment event, and then I was very excited to be told that I'd been appointed to the position. And so really that gave me an opportunity to take some of the, I think, the wider international science policy work that I'd been contributing to. And also I hadn't realised that by working internationally, many of us as scientists, we have collaborators around the world. And in astrophysics in particular, the kinds of facilities that we need to use, exploit, develop, and fund, we can't do that as only one country. We actually have to come together with countries around the world in order to build these big facilities. And then we work in big interdisciplinary teams as well. And so that made me realise that actually I had always been projecting international science and connecting internationally. And so the way that role worked was actually 3 days a week secondment into government and 2 days a week back at the University of Bath, which was fantastic because I could then combine the best part of academia with that international facing and really have some credibility in both. So that role really was kind of three main parts. So first of all, being the head of the government science and engineering part of the civil service within my department. So being a champion for those people who had a science background, and also helping to train new diplomats coming in on the non-science fast stream about how to use science and science diplomacy in their wider diplomatic, geopolitical and foreign policy work. Science advice in emergencies, so obviously all of the CSAs can be drawn into SAGE, and it's a very famous group now because of COVID, but really important that that's a mechanism that Sir Patrick Vallance can use at times of crisis when he has to give advice to the Prime Minister. If that advice requires complex and interdisciplinary science advice, he can draw all the right people into the room. So back in 2019, there was heavy rainfall and there was a dam in North Yorkshire that was at risk of collapse. So obviously I didn't need to be on SAGE for that because that was not internationally facing. But when we first started to hear about this novel coronavirus emerging in Wuhan, that was when SAGE was scrambled. And then obviously I became a participant in that. That's really been a big part of my work over the last year. But more broadly within the Foreign Office, we have an international network of science and innovation attachés who are within our embassies. So about 100 SIN officers sit across 50 countries. I think it's the biggest network that any country has for science and innovation. And they are wonderful experts who sit within country, and they understand the science and innovation landscape within that country, and they help us to deliver our international objectives, and also to help our science ecosystem back in the UK connect with those international science systems to help people build collaborations and really to help that people to people relationships, because even and particularly at times of political crisis or with countries that we may have difficult diplomatic relationships, our scientists are still working together, and it's keeping those communication channels open is particularly important. And then of course we have a global pandemic, so we've seen really the power of science to help to transform and tackle some of these biggest challenges. And then of course climate change is the biggest challenge that we have, I think, as a species. And so for me, this international collaboration really sits at the heart of the work that I do.
Fantastic. So did you find it was natural to balance those duties as at the Foreign Office with a continuing academic career, or did you find yourself having to make decisions about which to prioritize?
Yeah, I mean, I would say that they complement one another very much, but my calendar is very, very full. So I had a wonderful line manager in the Foreign Office when I first joined, and one of the questions at interview was, what was your greatest success and what was your greatest failure? And I certainly put work-life balance down as my greatest failure. But he was fantastic because he said, oh, that's fine, we'll work on you. And what I've learned is very different working practices in the civil service than I have in academia. The very first question I was asked by my team when I arrived in the Foreign Office was, how do you like to work? And I said, well, I'm an academic, I work long, hard hours. And they said, okay, we'll figure you out. And it's been fantastic. It's been a really interesting learning journey for me, learning how I assimilate information. So for example, if I do a visit in country, I will have a very, very broad and deep portfolio. I'll have lots of different stakeholders I'll be meeting. So I'll have to read very broadly across all of the policy areas, all the different science areas. And I've learned how I assimilate information, what kind of learner I am, and what support I need, right down to how a page is formatted, what font I use. These were all things that I never knew really were issues to even think about as an academic. And so I've become much more efficient, and also how you enable and support your teams to deliver to you and how you deliver back to them. We have lots of conversations about objectives, ways of working, how to be efficient and how to deliver to deadlines on time, whilst also creating the space for strategic thinking and actually consultation, which is a really interesting way of working. And I've tried to bring some of that back into my academic work and support particularly as early stage career researchers and students when everything starts to become very busy, or you hit times of challenge as we have in lockdown and COVID. How do you prioritize your time, and how do you say actually what's really important for me, and how do I juggle the many commitments that we all have so that we can actually do one thing at a time, because we can't do everything simultaneously. So that's been a really interesting piece of my learning as a senior leader, I guess, both now in Whitehall and also in academia.
That does bring me to another question I was going to ask, which is known as an issue in academia, and as you said yourself, work-life balance is something we all struggle with, particularly in the sort of the post-PhD career, but not always. It depends what stage you are in your career, what age you are. But often we have to balance family matters, whether that's the famous 3-body problem of how you move around in academia with a partner, or if you have children, how you balance parenting with an academic role. So what was your experience of doing that with at the same time as looking out for gamma ray bursts?
Yeah, so I have 2 sons, and as I was building my research team around gamma ray bursts, I had my first son. So I think, first of all, having a fellowship at that time, I actually had 2 fellowships concurrently, gave me the flexibility to work the way I needed to work. My son was very good at sleeping through the night, but then I was being woken up by the birth cries of new black holes forming in the universe, getting a signal from the satellite and making my phone buzz. But what I realized, and this also was how I managed my team as well, is that actually having clear objectives and delivering to those objectives, however you do it and wherever you do it, was really the way I led my team. And I think we see this very much in COVID time now. So if we were up in the middle of the night chasing a gamma ray burst, putting circulars out to our international community and negotiating paper leadership, I definitely did not expect to see my postdocs sitting at the desk at 9 o'clock that morning if they'd worked from 2 till 6. So my approach was, we've done this great piece of work, it's delivering wonderful science, and we're now developing an international reputation really from scratch. So I'm not going to sit and say, why are you not doing 9 to 5 at the desk? And I think that created, a lot of trust and cohesion within our team. They also saw me working. I was in the middle of the night getting my hands in the data too. I wasn't just being a boss and saying, go ahead and do that work and I'll turn up in the morning and gather the fruits of your labour. I was really there with the team doing it together, but then using my experience to add the extra leadership piece on. And I think also that was really important for my son as he became a toddler. Again, that work-life balance, being able to be a little bit flexible. So one Saturday afternoon, we had some issues. We ended up setting a rota up so we could support the team, so we weren't all working all the time. And something had happened, with a colleague. And so I took that duty on the Saturday afternoon at short notice. We found a gamma ray burst, and it was important. We had to put a circular out. We'd made a discovery. It was a very ambitious and competitive field at the time. But my son was waiting for me to play with the jigsaw. So suddenly I had that decision, and I said, well, come help mummy find a black hole. So we did a game where we flicked images on the screen, and I said, can you see the thing flashing? And he got to press the button to send the email out to 1,002 astronomers around the world. And then I shut the computer. I'd done my work, I triggered the next set of observations, and we went and played jigsaws. So for me, that was a very exciting time. And I think I've taken that learning through. So I think, there are times when you need to be physically somewhere. If you're in the lab, you need to be able to do that experiment. Sometimes you'll have a very intense period of your time where you really do want to deliver to something, or you're writing your project up, or you've got a deadline to submit, and then you might work very long hours, but actually you can't sustain that in the long term. And I think it's fair to say, I've done my 14 or 20 hour day, I've delivered my report, my document to my deadline, but now I need to take a few days and just step back. And that's really how you build resilience. For me, resilience comes from also not having to context switch all the time. So I've learned that as I've become busier and possibly become older as well, and my brain slowed down, that actually if I'm having to really switch from very, very different topics, there's a cost to that. So the way my team manage my time within Whitehall at the moment is I might do some very intensive externally facing broadcasts, and then I'll have a week of policy time. It's not always like that, but try to group things together. So that I can change the way my brain is working in chunks rather than having to constantly flip multiple times a day if possible. And then it gives you a bit more resilience when there's an emergency to deal with. And also to then finally put that family piece in so that you can say, well, actually, I have a gap here. This is the priority that I have to focus on now, because actually if my family aren't happy and safe and stable, I can't focus on my work anyway. So all of that comes together with sort of me as a whole person. You get the best version of me at work if all of that works together.
Great. I'm going to circle back to something you said earlier again as well. I'm going to keep doing this. But you mentioned, I can't remember what question it was you were answering, but you mentioned deleting emails because you didn't think they applied to you. And one thing that people are becoming sort of increasingly aware of is imposter syndrome, the feeling that we're a fake, we're not good enough for the rest of everyone else that we know in our field. So I was wondering if you could talk about any experiences you had with that, and kind of how you may have overcome it.
Yeah, definitely. I think it's very common. I think it's very common in physics, actually, and I think it's particularly common for women. So I think there are two things. I think to be a good scientist, you need to have humility. You need to challenge your underlying assumptions, and you need to critique your own work. And that's actually an important part when you go into research. I mean, at undergraduate level, when you're working on a research project, you might rely on either your project partner or your supervisor at the time. But as you go through your PhD, the goal of a PhD is actually to help you to develop those skills to become an independent researcher. And one of the skills there is to look and say, well, this is the answer I've got. How right do I think that answer is? And how do I quantify, or how do I explain the uncertainties? And then ultimately, how do I ask a good question so that when I get an answer to it, it moves at the frontiers of knowledge on? So there is a natural part within science where you do have to be some kind of humble. We also have peer review. So you submit a research paper, you get a critique back. Sometimes they can be constructive, sometimes they can be brutal and a bit nasty. And also we do things like apply for grants. And often, the really competitive grants nowadays are incredibly oversubscribed. And so you also have to learn how to deal with lots of rejection, actually. And so lots of that can be very personal. You can really internalize that. And I think the problem with also sometimes when, particularly in physics, we have very little diversity. And so when you look around, naturally you think, well, I can't see someone who's like me, so maybe I shouldn't be here. And that can also really feed into the imposter syndrome. So I think if you're not wondering whether, you're doing something right, then you're probably arrogant. So the people who never have any doubt are probably a bit of an extreme in the field, and we need to dial that down a little bit. But also if your kind of self-reflection becomes crippling, and you can't move forward, then I think that's a real problem. And the way to deal with that, I've found, is to network and find like-minded people, work with people who give you energy. And after you've had a conversation, whatever it is, with a friend, or whether you're talking about your science or your career, if at the end of that conversation you feel energized, then that's a good person to connect with. And actually, I'm hoping that as we really push forward on diversity agendas, particularly within physics, and physics is egregiously stubborn in this area, that people will start to have a much greater sense of belonging. And when you feel you belong, then things become easier, and then your ideas come more easily, and you can actually be more creative because you're not constantly thinking, am I okay, should I be here? Because that's a real tax on your intellectual and emotional energy. And so I think that's for all of us who are senior to be able to say, yes, we need this increased diversity because we need all of the ideas in the room. Then you can take a risk and you can put an idea out and you can figure out how it goes. I have colleagues who I can say, this might be a crazy idea, but what do you think about this? I trust them with my early ideas, and they'll come back and say, that's interesting. Yeah, let's think about how we can, develop that if they're a theorist and I'm an observer. And I have other colleagues who I'll do that to, and they'll immediately kill the idea. And at that point, I think, okay, that's not going to be an interaction I'm going to repeat. And I've learned to say, maybe that's you and it's not me. So I'll find someone else to socialize my ideas with.
Great, thank you. As we're getting on with time, I think it's probably time to turn to the participant questions. So bear with me as I just change my tab to see what we've got. They've come up on the screen, fantastic.
Lovely.
So what have we got here? Have you ever doubted yourself and your abilities when comparing with your peers? And if so, what have you found helpful?
Yes, is my answer there. I think what I found helpful is focusing less on other people and focusing more on ideas. So, what is it that makes me excited? What gets me up in the morning? That helps me to move away from what is everybody else doing and think about what's the issue. So going into the science, reading more broadly, and actually letting my ideas spark. And then deciding, as I said before about imposter syndrome, deciding with whom and when I share those ideas. And I think, you know, that also reminds you, particularly in academia where there is the constant critique, it gives you also a sense of why you're doing science. You know, actually you could leave academia and go to a company and earn lots of money. You know, you may choose to do that. That's a great path too, and you'll meet different kinds of challenges there. You might be comparing your salary with your peers. You know, there'll be all sorts of different comparisons. But I think you actually have to come back to what you want out of life. For you, what feels like a good life lived, and what do you have to do in order to create the life that you want according to your values. And that helps to ground you. Then you can do a bit of a sanity check, and actually you might find, I've got a skills gap, I'd like to do more reading or get some training or ask help from a supervisor or a mentor, because mentors also have a really important role to play here, mentors and sponsors, informally or formally. You know, speak with someone who's a bit more senior and say, this is what I'd like to do in my life, how should I go up that path, rather than constantly comparing with peers. Then you have that independence.
Great. Next on the list we have here, how can you distinguish friendly behavior from inappropriate behavior from men in the workplace? As women, I feel we naturally have the tendency to be extra defensive in a male-dominated setting, and it's very easy to misunderstand friendly behaviors from uncomfortable ones.
Well, I think first of all, you know, discomfort is a personal thing. So for me, we all have our boundaries, and those boundaries will be different in different settings and at different times in our life. So if you feel uncomfortable, that's your feeling, and I think that's fine. You can own that. I think communicating it can be helpful. I've also found, I guess, extra defensive. I've actually seen the opposite in my career, that women's threshold tends to be quite high. We tend to explain away and assume that uncomfortable behavior is accidental and well-meaning, when in fact it can actually be the opposite. So I think sometimes being quite honest with yourself about what you think is happening. If somebody is being deliberately invasive and is making you feel uncomfortable, whether they know they are or not, sometimes they do know, and it is quite a deliberate power play. Sometimes they don't. It's okay to actually say, these are my boundaries and I'd like if you would respect them, because for me it's about mutual respect in the workplace. These are very difficult conversations, but I think we're having them much more now around the whole hostile workplace, sexual harassment and Me Too movement. And, you know, again, talking to male colleagues, I know that can be a really difficult conversation, but sometimes just being able to say, when you do this, it makes me feel like this. So maybe we can find a different way of working together. It takes a bit of courage to do that, but it also lets you have that conversation so the other person can say, you know, I had no idea, but let's work in a different way. And also if that person says, actually, no, I was doing it deliberately, you then also really understand what the power play is that you have in place. So yeah, I mean, I think, you know, you feel the way you feel, and that's actually valid and acceptable. And then you can find a way to either communicate that or speak to other people around you as well, if you are thinking it's something more systemic.
Thank you. Yeah.
And I think I would also just add to that, you know, that our male colleagues have a really big role to play here. So in, you know, male-dominated fields, it's often the women raising their voice and saying, I don't know whether this is comfortable, but it's a really strange thing for me. Whereas actually our male colleagues have a really big role to play here too, to actually be able to call out those so-called microaggressions, sometimes they're not so micro, and actually raise up women's voices. It can be something as simple as you're in a group and there's the New Yorker cartoon where it's men sitting around a board table and there's one woman, and the caption under the cartoon is, "Thank you, Miss Triggs, would one of the men like to have that idea now?" So I think there's also raising up, you know, minority voices. So our male colleagues have a big role to play there too.
Absolutely. So our next question is, did you notice a difference in the way people interacted with you as a woman when you transitioned your career from undergrad to postgraduate?
Yeah, that's a great question. And I was really fortunate that I found the environment at Jodrell Bank to be very supportive. It was very male dominated, but it was actually a very kind of warm and supportive place, and championed their students. So the 4 PhD students in my year, there were 2 women and 2 men. I think that helped as well. So I did find that I was quite confident and comfortable in that setting. Probably less so at undergraduate, actually. And also at school, I was one of 3 girls out of a class of about 40 odd boys in my 6th form. and I was the only one that went on to study physics at university. So I actually found it slightly easier at PhD than at undergraduate. And then it's changed at different points in my career. I've been in some environments that I've found supportive and others that I've found actually really quite hostile. So I think it depends as you go along and you develop different skills to be able to deal with these things.
So how did you know you wanted to go into academic research rather than into industry?
I haven't decided yet. So as I said at the beginning, you know, I really loved the summer job that I had in the company that I worked for, and it was also quite research based, and there was also, you know, the real option of doing proper training, how to write reports, how to do project management, all of the things now that we actually help our PhD students learn. And I think because I was given that option to then take that job up after I'd done my PhD, it really meant I could really enjoy my PhD. I didn't say I'm going to do my PhD because I'm going to grow up to be a professor in astrophysics. That was never a career plan for me. And so it was always really nice to think that I could go back to that company. They said, obviously, we can't hire you at a higher pay level because astrophysics isn't relevant for this job, but we'd love to keep the position open for you. So I think that gave me a lot of flexibility to enjoy the PhD. As I went through that, I discovered I really did enjoy research. And I thought, well, you know, I'll apply for a fellowship and see how far it takes me. But always thinking that I would probably ultimately then go off into industry anyway, because I'd really enjoyed my experience there. And then I was able to sort of craft the opportunities. I was quite strategic. I took the postdoctoral research position in the United States. Partly because it was a really exciting opportunity, but also because I saw that postdocs in the UK weren't getting permanent positions. It was people coming from abroad that were winning those fellowships. So that was a very deliberate strategic choice to apply for overseas positions. I was engaged to be married at the time. My partner stayed in the UK. You talked about the N-body problem, Imogen, and you know, he stayed in the UK. I went to live in the US, and that was a strategic decision that we made as a couple to give me a better chance in my career to then apply for the kind of positions I wanted back in the UK, which was ultimately where we wanted to make our life.
Great, thanks. Oh, here's a question. Did you feel like you didn't love physics enough compared to your peers since you had other interests?
No, I didn't. I love physics. I love equations. That's my sanity place. So when everything else is going wrong, I go, oh, you know, I get completely absorbed into an equation. No, the best physicists do other things, right? I mean, if you look at someone like Sir Roger Penrose, who got the Nobel Prize last year, you know, he's such a creative theoretical physicist. He uses his imagination. You know, he and his father did these amazing sort of Escher-style geometry puzzles. He's a mathematician. So I think for me, physics is an incredibly creative, imaginative subject. And when you have those other interests, it's not just physics, but actually when you step away from what your core day job is, that's when your brain really starts to think. You relax and you let your brain do things that you couldn't do consciously. I'm not a neurologist or a neuroscientist, but that's my feeling, that actually when I've got really stuck on a problem, it's when I then stepped away to do something else that then the light bulb comes on. I think, oh yeah, I know the solution to that. I'll go, I wonder if I'll then come back and have a look at the problem that I've been struggling with. So yeah, other interests are great. And equally, you know, physics is your other interest. You may develop it that way too. I think that's fine too. But don't feel afraid to do other things.
Yeah, great. The next question is about imposter syndrome. We already touched on that.
I think I'd also just add on imposter syndrome. I don't know if everybody's heard of this, a thing called Dunning-Kruger. You can look that up. And imposter syndrome is a tiny piece of a graph. So since I'm speaking to physicists, just Google Dunning-Kruger, D-U-N-N-I-N-G. And it's kind of half in fun, but it's not actually. It's a psychology term about levels of expertise and levels of self-doubt, and then how that turns into arrogance or how it turns into expertise. So there's all sorts of different versions of graphing that expertise versus confidence plot. But I think imposter syndrome for me is a tiny piece of the overall Dunning-Kruger effect.
Yeah, I think it's certainly true that as you develop your expertise for what you know what you don't know.
Exactly. And what you don't know grows. Yes.
Exactly. So the next question is, how can a woman balance family and work without compromising her career aims?
Yeah, so two things I would say here. I would rephrase that question to how can people have lives, right? So, you know, we all have different things in our lives. We may, as we get older, have, you know, caring responsibilities for dependent relatives. We may have hobbies that we want to pursue. And so I think the conversation needs to broaden out. I think the weight shouldn't only be on women's shoulders. And this is something that we've seen in the COVID crisis, that women statistically are more disproportionately affected by caring responsibilities, homeschooling their children. And so actually we have to broaden this out and have a societal conversation. You know, we have to say, well, families, in all sorts of different varieties of families, designed in all sorts of different ways and different partnerships, have lives that they want to find fulfilling. Having a career is part of that. And I think we have to start to change the way we define success, because that's over the entire, you know, length of your career. How do you make an impact? And I think we struggle particularly in these very classical male-dominated fields like physics. This trope that to be a physicist, you're extra super cleverer than everybody else. I actually don't believe that. I think every field requires intelligence and dedication and hard work. There are studies that have shown that girls and boys as young as the age of 6 identify with the stereotype that boys are naturally clever and girls have to work hard. If you then add on to that the misconception that physics is hard, what that tells girls is that you will have to work much harder than boys to be equally successful as boys in physics. And that can actually be a real turnoff. It can also really affect how parents think about what their daughters want to grow up to do. So for me, as I said about juggling my career, I think there's flexibility. There's also thinking on the long term. Where are you trying to get to? What does good look like for you? And what can you do at the point you are now in time to make sure that that works? So certainly I designed that flexibility into my career for my family. I was very fortunate to have a supportive family. I know not everybody's lucky enough to have that. And also we made very strategic decisions about where we wanted to live in the world and how we wanted to make that work, and we had a backup plan. So I think, you know, you have in your life what makes you feel fulfilled, and I don't think that they're mutually exclusive, but we are really trying to challenge employers to understand that women and family is not a single axis, that it's actually people, lives and talent, and contributing to, you know, that wider good, that talent retention and development. And also, you know, if you are, your partner will also be impacted, you know, if you're in, you know, I guess a, you know, male-female relationship, then this impression that dads don't want to actually have time with their families is also something we have to get away from. Women are caring, men are ambitious. That terrible stereotype. We need to break those barriers down too.
Okay, thank you. So the next question is, have you experienced any difficulties with progression due to your gender on your path to the position you're currently in?
Yes, I would say I have. And it's something that has gradually become a realization to me, particularly as I've become a senior woman. Again, you can't be what you can't see. I mean, you've got some incredible speakers on this conference. So you'll hear from the likes of Professor Dame Jocelyn Bell Burnell. For me, she was an incredible role model, and she was one person. You know, that's really, really unique and kind of isolating as well. And she speaks very eloquently about what it was like to walk into a physics class and be the only girl, you know, out of 140 students or something. So what I've noticed really is really subtle, I guess, patriarchal power structures in organizations. And they're not always obvious. And it's not until you actually look where the power and where the money is that you then start to realize, gosh, these are hidden barriers here, and that we actually need to start to deconstruct those. At the University of Bath, it's a physical sciences and engineering focused university. And so there are some legacy structural issues that we're trying to tackle. And very, very slowly, we've started to build up over many years the talent pool of women. So now I've got a network of senior women colleagues, but they're not within physics because there aren't enough in physics. And so I now reach out across engineering and across other fields. And also internationally, there are many other networks that are starting to connect. So I think this forum here is absolutely fantastic for you all to make your connections. You will be senior colleagues. Whatever you go on to do with physics in your life, you should keep one another's contacts so that wherever you are, you can always connect at any point in your career. And I think those networks are really important, and that's what helps us to tackle those subtle gender stereotypes. There's also other hidden stereotypes, like working part-time, for example, this sense that if you work part-time, you're no longer committed to your career, or you have a family as a woman, therefore you couldn't possibly be any more committed to your career. And I've hit those sorts of barriers without realizing that was how people saw me, because I didn't see myself that way. And then suddenly you think, gosh, people have seen me differently. So I had a boss when I had my first son. I was on a Royal Society University Research Fellowship. They knew I'd taken maternity leave. I'd come back from maternity leave, and the Royal Society had written to my line manager and said, would you like to propose her for a promotion, a merit increment? And I went to my boss and I said, I've had this letter, are you considering proposing me? And I'm happy to help you with that. And I'd worked very hard before I went on maternity leave to make sure I had good papers coming out. And he just looked me from head to toe and he said, I don't think there's much point, is there? You've just had a baby. And I felt as if I'd been literally kind of punched in the face, because I hadn't really noticed that I was a woman at that point. And I thought, oh my goodness. And I said, do you not want to see my CV first before you decide? Like, do you want to see the evidence? Kind of shrugged his shoulders and said, okay. Obviously, I didn't get it that year because I don't think he could have written a very energetic letter, and I got it the following year. But that really shocked me, and it made me realize how people saw me, even though that wasn't how I believed I should be seen. Similarly with part-time work, I'm now part-time in 2 jobs. So you get to see what it's like to be seen as a part-time woman in a field, particularly in physics, where you have full-time men working to advance their careers. So we have to take down all those stereotypes and barriers.
Yeah. Right. Next question. I'm going to skip down one because I think this could be an interesting one to ask. Do you feel it is better to start a family earlier in your career or wait until your career is more established?
I would say there's no right answer to that. I think you have to do what you feel is right in your life. So I know I have colleagues who started their family very, very early. Maybe through their PhD, even sometimes under their undergraduate, and they had the right support structures in place, or sometimes they found it really difficult, but they got through it. And then they're young parents and they developed their career in a different way after that. I was a little bit later, so I was 33 when I had my first son, and that was just because of the way my career came together. But again, it was a conversation that I had with my partner. I also know that, as we go through, we're having some of these conversations sort of in my workplaces around infertility and women's health. And actually, you may say, well, here's the ideal time to start a family. I've got all of this set up and now this is the time we've decided. And then it might not work out for you. And so that's also something to think about, that actually it's about all of your life goals, your health, your finances, and where you make a decision. And also what sort of support you have in your workplace. It's a conversation that you might want to have with your supervisor or with your line manager. Actually, what are the processes and procedures in my workplace, and what opportunities and what rights do I have? Think about that just, before you embark on that journey, so that you have the right kinds of protections.
Thank you. I think we've probably got time for maybe one last question. So how about this one? How do you build experience, and which experience should you choose to be more likely to be chosen for PhD positions?
Yeah, so I think when I'm interviewing for PhD students to join my group, I think the first thing I'm looking for is a real commitment to the subject, so a real spark of interest. And doing a PhD is exciting, and sometimes you hit times where things don't work out and you need some real resilience to get through those times. I always say to students when they join, first year is really exciting, we want to solve the wonders of the universe. Second year is when your code stops working and you can't figure it out, or you can't get past a data problem, and you eat lots of chocolate and drink lots of coffee and you think, why am I here? Often when imposter syndrome kicks in, or your experiment isn't working the way you expect it to. And then third year is when you think, it's impossible, I'm writing up and it will never end. But actually to step back and say, do you love the subject? Have you had a little bit of research experience at undergraduate? I think most students now do some kind of research project. And then personal self-reflection. What did you get out of that? What did you enjoy? What did you find was challenging? And that's the sort of thing that I will ask at interview. What did you do? Not what the whole project was, but what did you do? What did you learn in that? And why do you want to do a PhD? What is it that you've taken out of that experience that you then want to take looking to further research. And, you know, sometimes I'll ask what, you know, longer term career goals are, but not always, because sometimes you don't know, as I didn't when I went in to do my PhD. So, you know, I think you don't have to be already able to do a PhD when you join as a PhD student, because it's, again, there's lots of opportunity to learn. But I think having the commitment and the dedication to do that and showing that you've enjoyed doing something similar as an undergraduate is a really interesting way to do that. If you're coming from a different career path, again, I've, you know, worked with students who've maybe gone off and taken a job after they've done their undergraduate studies, they've worked in industry, and then they said, actually, I'd like to come back and do a PhD. I worked with a brilliant chap who now is a postdoctoral researcher, and he'd gone off and he'd had a job and he'd decided, this is what I really want to do. He had a family, and he brought all of those experiences and some of the challenges in his life to the PhD, and he's a brilliant theorist now.
Fantastic. I'll open up the floor to you, actually. For the very last question, I suppose, should be, is there any last piece of advice or final thought you'd like to share with our undergraduate women here?
Yeah, I think two things. First of all, work with good people. Find good people that make you feel good about yourself, because life's too short, right? You know, the universe is 13.9 billion years old, and we are sentient beings for such a tiny fraction of that. So, you know, if you're in a situation that's uncomfortable or bad for you, then change, do something else, figure out who are the good people in your life and look for those. And I think secondly, you know, I just have to sort of say thank you to all of your delegates here, because you're who give me the inspiration to keep on pushing some of these barriers, because actually physics is a wonderful field, however you use it in your life. And actually we should be able to get on and do that science. So some of the big challenges we have in our workplaces with gender bias or sexual harassment or racial harassment, all of those things, you know, we have to keep tackling. But the reason that I have the energy to keep on talking about those subjects and challenging structures and institutions about it is first of all because we've got, as I say, big global challenges to solve. And also there's all this talent, you know, there's 109 brilliant people on the call here. You are all going to go out and be those change makers. So I find that incredibly inspiring that there are 107 of you on this call, and this conference is also incredibly influential. Every year I know that, you know, the women undergraduates that I know, I say to them, do you know about this? And they think, gosh, you know, this is a fantastic thing for me to connect into, to help that isolation within their local environment, and to know that there's a bigger world out there. So I just think congratulations to you on this wonderful conference. I'm hoping to join later to hang about in Gathertown on the poster session. So I'm really looking forward to seeing what you're all working on, and do lots of talking about your science, because this is a real opportunity to share what you're working on. And you know, you'll create new connections and new science frontiers by having those conversations about your science. So thank you so much for the opportunity to speak to you today, Imogen.
No problem. Thank you so much for coming. It's been a fascinating discussion. I hope everyone else agrees. I certainly feel privileged to be on this side of it. So as you said, you'll be back for the poster session in Gathertown. So everyone else look out for Professor Mundell there. And I hope you can have some good discussions later on then.
Thank you. Really looking forward
So thank you for
to it.
coming.
Thank
Wonderful
you.
to have you. Thank you very much.
Thank you. See you later. Bye-bye.
Bye-bye.